Alright, good day everyone. Uh, I was not able to meet you last Thursday, no, because I have an emergency meeting. And yesterday we had no class due to the transport strike, so the class was suspended. So I made this video discussion so that uh, we can still have our examination on Monday. And then last topic naman kasi, projectile motion. This is still part of curvilinear motion as I've said. So for curvilinear motion, yung coverage lang for that will be included in your first exam will be ano lang no, will be rectangular component saka itong projectile motion. Okay, so let's dive right into projectile motion discussion. So una, let's define muna projectile motion. Projectile motion is the 2D path of an object launched into the air, moving under only gravity's influence, neglecting air resistance. So that is the assumption class that we are to neglect air resistance. But in reality, meron talagang air resistance, no? For easy analysis, so sa projectile motion, ina-assume natin na there is no air resistance or yung air resistance is negligible. It follows a parabolic trajectory and is analyzed by separating it into independent horizontal or the constant velocity and vertical which is a constant acceleration due to gravity. Class, you need to understand that in projectile motion, yung horizontal component ng velocity mo or ng velocity mo would be under the domain ng constant velocity. So pag constant velocity, if we try to recall, yung distance will be just equal to your velocity at x, okay, at x direction times time. Okay? Yan lang yung formula na usually na ma-apply natin if we are dealing with constant velocity. Pag constant acceleration naman due to gravity, pag due to gravity, that is considered to be free falling. Okay, free falling yan. So, pag ganito, we can use the formula ng free falling. So, we have here, so for example, y is equivalent, or height na lang, height is equivalent to velocity initial at y direction times t minus 1 half gt square. So, yan, gamit natin to most of the time. And ito naman for constant velocity. So, let's say for example, we have here our object. Ito, class. Ito. So, initially may velocity yan, denoted as VO, initial velocity. So, itong VO, may X and Y component din yan, no? So, initially, if our object is at Y sub 0, initial position niya, and we still have also X sub 0, yung initial position along X naman, okay? Uh, So, ito yung direction or yung velocity, no? So, it will follow a parabolic trajectory. Ito yung path na uh, ma, ma matitrace niya. And so, if we will be evaluating it in this position, so meron na siya ang x position and y position. Yan na yung final x and y position niya. So, meron din siyang velocities horizontal velocities and vertical velocity components, no? So, kapag horizontal motion, your acceleration will be equal to 0 kasi we are in constant velocity na domain. Kapag vertical motion naman, again, that is constant acceleration. Okay? So, yan, no? That is due to the influence of gravity. Sige. Now, so, yan, no? Nakita nyo? Yan yung magiging path ng object natin. So, let's now uh, uh, talk about the formulas na involved in projectile motion. Una, yung v sub y at initial velocity at x. So, makukuha natin yan using pang trigonometry lang. Ito yung theta class or the angle of your initial velocity with respect to x positive. So, kung kukunin natin yung v sub o sub y, that is sine, no? Kasi opposite siya ng angle. Kapag yung vox naman, that is cosine kasi that is adjacent side ng angle natin. Now, yung sa horizontal motion, which is acceleration is constant or constant yung velocity, yung Vx niya is equals to the x component ng initial velocity. Okay, same lang ito. And then, ito yung magagamit natin most of the time. Wherein, most of the time, yung x sub 0 is actually 0. kasi nasa initial position tayo eh. So, ito yun. X is equals to V sub X t, wherein ang V sub X is the X component of the initial velocity of your particle's velocity. Yan yun. Kapag naman vertical motion, so ito yun. May V sub Y tayo plus that is equal to V sub Y initial. This is final ha. This is final velocity at Y direction or vertical component. Ito naman yung initial velocity at Y component plus G, wherein G is 9.81 if we are dealing with SI, 32.2 naman if English. Okay? So, eto magagamit din natin yan. This is final velocity along Y. This is the initial velocity along Y square plus 2G Y minus Y sub 0. Okay? And ito, most of the time ha, ito magagamit natin. Okay? Sige, meron ding relationship yung vertical at horizontal component. Ito yung relationship nila. Saan to nakuha? Dito lang yan nakuha. Okay, if we try to recall, no, from this equation, ito class. Since, you need to understand pala this one, na if we have, say for example, an object right here, then the object will trace this path, no, as it is being launched at this position at a certain angle. Okay, so for example mapunta yan siya dito. Ang time, okay, you need to understand that the time it takes for this object, kung kukunin natin yung, let's say for example, uh, gawin natin is that we will consider pure vertical motion. Okay, mangyari niyan ganito. Object, papunta sa itaas. This is the peak point and then baba. Okay? And then meron yun siyang time na mako-consume. Okay? Sa projectile motion, you need to understand that the time na mako-consume nito, if we are dealing with vertical motion pure, that will be equal to the time that it will be consuming or that will be spent, okay, from this position to this position pag horizontal tayo. Okay, you need to understand that one. Okay, nakuha nyo? Again, I'll repeat it. The time na matitake or mako-consume ng particle as it moves in this direction pababa, that is time t, that is the same time na mako-consume naman niya if the object will move purely horizontal from this position to your final position. Okay? Nakuha ninyo? Or if in this case, if our object will have this motion, no, papunta dito sa itaas and then baba kung saan to baba, ayan, ito dito, mayroon time siya makakonsume. That is the same time na makakonsume naman niya if from this position right here papunta dito. Okay, that is the same time t. Okay? So, with that being said, galing doon sa formula na x is equals to vx t, since t is const or is equivalent sa dalawa, and then we have here y equal to vy, okay, vy t minus, actually this is minus guys because gravity is downward, no? So pero dito i-plus plus lang yung or added lang yung dito, and then ito should be negative. Okay, pero para mas easy na lang, negative lang yan para diretso na uh, positive yung gagamitin natin dyan. That is 1/2 gt square. Okay, and then since time is constant, or I mean to say the same for x and y, so therefore from here we can say that is time is equals to x over vx, wherein ang vx is initial velocity cosine theta. Tama ba? And ang vy, since vx and vy is equivalent to initial ha, initial lahat to, vo cosine theta, and then we have here vo sine theta. Okay? So with that, so from here we have here y is equivalent to yung vy, again that is vo sine theta. And then we have time, which is equivalent to x over vo cosine theta minus, okay, minus 1/2 g yung time x over vo cosine theta square. Kaya ito cancel to, vo, mangyari niyan x, that is x, then sine theta over cosine theta is tangent theta, minus 1/2, and then we have g, then we have here x square over vo square cosine squared theta, and that is the same thing as this one. Now, meron tong dalawang orientation or setup class. If say for example, this is your initial point, then you project, you will launch your particle and then mapunta dito, baba ha. So this is your level point at to which level yan ng launching point mo. So kapag ganito yung setup, yung y natin dito would be negative y. Okay, yan ha. You need to understand that one. Itong y dito, measured from this point papunta sa saan yung ah, destination ng ano mo, yung particle, that is negative. Kapag naman, say for example, this is your launching point, and then this is your level point, then yung projectile mo mapunta dito. So, measured from ito axis, that is positive naman. Positive y yan. Okay? And then always negative to ha. Kasi ito, although positive dito, this should be negative 9.81 or negative 32.2. Nakuha ba? Okay? So, ito, positive, negative, depending on kung saan siya maglaland. Kung above this reference point, okay, that is positive. Kung below that reference point, that is negative. Okay, meron kasi mga problems later that we will be considering kapag naman dito, baba sa reference line mo. Okay? Sige. Siguro, let's try to illustrate some example para mas, ano natin, no, maintindihan. So, let's try with example number 1. The chipping machine is designed to eject wood chips at velocity 25 feet per second. That is the initial velocity as shown in the figure. If the tube is oriented at 30 degrees from the horizontal, determine the time. So we are to determine first the time and how high, so that's letter B, how high h the chips strike the pile if at this instant they land on the pile 20 feet from the tube. So ito, meron tayong tube. So basically, gamit yung chipping machine, if we chip from a entire, ano no, entire plant, then i-chip natin yan to, or magiging fragmented yan, no? Okay, so, sabi dito, yung tube daw is 30 degree, yung inclination niya. Okay, so we need to solve for the value of, first the time, and the next one would be the height. Now, you need to consider, na nakikita nyo, yung A dito is nasa baba ng reference line natin dito. Tama ba? Nasa baba yung A sa reference line. So, we would be expecting that your, so for example, sabihin natin this is YA, that is negative YA. Nakuha ba? That is negative YA. And from here, so YA is basically equal to your 4 minus etong H. Okay? That is your YA. Negative siya ha. So that is negative 4 minus H. So we will be using this one no later. Okay, sige. Let's first determine muna yung time. Again, sabi ko, the time it take from these sabi dito mga wood, no, wood chips from this point papunta, let's say for example, papunta dito sa ibaba, tama ba? Yan. That is the same time na makokonsume niya if from this point initially, this point papunta dito. Okay? So, pwede natin gamitin yung x is equals to VOX t. Wherein yung VOX, that is the initial velocity at x x-axis or x component, no? So, times t. So, kukuha lang natin yung time. Since we are given with x already, that is 20, so this is 20 equal to, yung velocity natin is 25, then cosine 30 times time. Okay, time therefore is equivalent to 20 over 25 cosine 30 times 0.9237 seconds or 0.938 seconds. Okay? Okay, that is our answer for letter A, number 1. Okay, that is the time. Now, next would be the value of H. Okay, for value of H, that is just equal to, so gamitin natin na yung negative YA is equal to, since we now have the time, no? Pwede natin gamitin yung velocity initial at y, then we have here time minus 1/2 g t square. Okay? So, yung negative YA, again, that is negative 4 minus HA, or H lang, no? Is equal to VOY Again, ang VOY is VO, okay, sorry, VOY is equals to VO sine theta. So in that case, that is equivalent to 25 sine 30 times time, which is 0.9238, minus 1 half. Then we have here, since this is English, so this is 32.2 times 0.9238 square. Okay? So therefore, H would be equal to, sorry class no, if medyo noisy yung surrounding ko. So that is basically equal to what? So negative, okay, sorry, negative 4, sorry, 4, sorry, minus x, ayun, x na lang ating magiging h is equal to 25 sine 30 times 0.9238, okay, minus yung 1.5 or zero point 0.5, sorry, times 32.2 times 0.9238 square, and that is equal to, shift solve for the value of x. Okay, that is 1.807, or that is about 1.81. Okay, 1.81 feet. And that is basically your answer for this problem. Okay, sige, let's illustrate another problem.